Hello everyone, my name is Pete Neal. I'm the ATG Product Manager for OPW FMS. In this short video, what we like to do is teach you the basics about automatic tank gauges, or ATGs. The biggest question that people have is, why do you need a tank gauge? The biggest reason why you would need an automatic tank gauge is to understand what's going on underground. Most retail facilities, when you look at what's underground, you have your normal tank, you'll have a motor, and then you'll have product piping coming out to a dispenser. Well, the problem that you have is that all of this is underground. You can't see any of this. So the biggest reason why most people will use an automatic tank gauge is because of regulatory requirements, either be federal or state, local municipality regulations, where you're looking at a tank. Well, let's say you have a tank that's just leaking into the ground, or you have your product pipe that's leaking into the ground. There are federal mandates that you have to do a tank tightness test, either a 0.2 every month or a 0.1 every year. Same thing with the lines. 3 gallon per hour line test after every dispense, and a 0.2 monthly and a 0.1 annually. So most people will install an automatic tank gauge to meet state and local regulatory requirements. But the other reason why most people will use a tank gauge is because they need to know what the level is when the person up on the ground can't see what's in the tank. So what he wants to do is he's going to take his stick, he's going to drop it in here, he's going to read that stick to see what the product level is. Well, when you look at this is costing you money because you're paying somebody to go out and do this as a manual process. By taking this aspect away, I can now put in an automatic tank gauge to be able to tell me how much product I have in the tank and how much water I have in the tank. So by just the implementation of an automatic tank gauge at a site, I meet two of the basic needs. One is regulatory, and the other one is knowing what commodity I have in the ground. When gasoline and diesel were 99 cents a gallon, nobody really cared about how much product they had in the tank or how much they kept in the tank. Well, when diesel hit $4.50 a gallon, everybody cared about how much product they had in the tank. Well, the automatic tank gauge was able to get them that knowledge, the awareness of what their wet stock product was. Well, the other thing that the ATG is able to do is that it knows how much product is leaving the tank through a dispenser. So it looks to see if the product that fell in the tank matches what was dispensed, and this is their monthly reconciliation. And this will tell them whether or not their meters need calibration, or if somebody is actually stealing product out of the tank, just siphoning it right off the tank. So the implementation of an automatic tank gauge is designed to meet the regulatory requirements, tell them what they have as far as wet stock volume, and it also helps them monitor theft through reconciliation. So in summary, why do people need or want an ATG, or an automatic tank gauge? Well, the first one, and the most important one, is probably monitoring for regulatory requirements. The second would be wet stock management. And then the other one is looking for a leak. Well, when you start looking at each one of these, your regulatory requirements, if you don't have this with an automatic tank gauge, the first thing that you have to do is you're going to have to go out and you're going to have to hire somebody to come out and do this. And this is looking for your monthly inventory management. This could be somebody on site, but this could be somebody that you have to pay off site that monitors your facility, pulling data from your stick readings and things like that. Wet stock management. This is somebody that you probably have at your facility doing this, where they're going out there basically just sticking the tank every day or multiple times a day. But at that point, now you run the risk of this guy on the tank pad with his stick. You have to worry about this guy getting hit by somebody that's not even aware that he's out there, getting hit by a car. So now you're worried about not only his safety, but you're worried about the safety of the tank, because while this guy is sticking the tank, if he's not careful, he can actually bust a hole in the bottom of the tank. So people normally will do an automatic tank gauge to prevent somebody from just constantly banging that stick on the bottom of the tank. The other one is the leak. Since everything is underground, you can't see it, you actually have to hire somebody to come out and test your tanks and your lines to make sure that they're not leaking. Well, the bad thing about all of these is that every time I add a person to the equation, what you're adding is money to each one of these. If they don't work for you, even wet stock management. When the guy's out sticking the tank, if he gets hit by a car, that could cost you more money than anything. But your leak test, this is where you're hiring a third party to come out and actually test the tanks, making sure that you're running either a 0.1 or a 0.2 test annually. And these can range anywhere between $150 to $350 per tank per line every year. So at the point in which you're looking for a return on investment, this is where you start looking at the return on investment, regulatory requirements, wet stock management, and actually doing the leak testing for that end user or that customer at that facility. If you remember in the earlier modules that we were talking about the fuel control systems at a commercial facility where you're monitoring the output of the dispenser into a vehicle. Well, what you're also going to do is in a retail or commercial location, all of this is being tracked either through a point of sale or through a local authorization. But you're monitoring what was being dispensed out of the dispenser. So if you're looking at tying in an automatic tank gauge to here, basically what you're going to do is look at what was being dispensed to the dispenser, what was actually being depleted in the gauge, and then coming up with the mathematical equation of what was dispensed versus what was delivered versus what is physically left in the tank. And what that will tell you is the variance for that particular product for that particular day. And this is where people look at wet stock management, is looking at everything that left the dispenser, what was dispensed from the tank, what was delivered back to the tank, and what's physically left at the end of the day, and coming up with a variance. Now this is where you start looking at regulatory requirements as well, because most states will tell you that you can have 1% of your throughput plus or minus 130 gallons, or some states say that you can have 0.5% with no overage, but you have to reconcile every 7 days, 10 days, 15 days, or every 30-day calendar month. But this is what an ATG will do for you. It will get you into your retail, your commercial, industrial, as well as your multi-use sites, but it's basically looking at the amount of product that is being dispensed and helping the end user reconcile his product level in the tank. So when we start looking at, we understand the why, now we want to give you a little bit about how. How does an ATG work? So if I look at the same mock-up that I had before, where everything's underground, and I've got my tank looking at it from the other direction. So basically what I'm doing is that I'm actually going to install a probe in this tank that sits on the bottom, and what you'll see is the fuel level inside this tank and the water level inside the tank. And on this probe, what we do is we put a float that will float on the product and something that will float on water. And basically what you're doing is sending a pulse down this probe, and then it gets reflected back up to the head, and wherever these floats are, you get a little bitty spike on a waveguide called a magnetostrictive probe. So what's happening is that I'm very accurately measuring where this float is on the surface of the product and where it's at on the surface of the water. And these probes are accurate to 1/1000th of an inch. So I can tell you very accurately what's inside that tank. Now, where it comes into play is that there's also temperature readings in 5 positions along that probe. So I can actually give you net corrected volume by measuring the temperature of that product in multiple levels inside the tank and actually giving you gross and net product volume. Well, the next thing that an ATG will do is that if I have a double wall tank, and basically what that is where I have the ability to put in a sensor in the annular space at the bottom of the tank, and basically what it's doing, it's looking for a breach in the inner tank to the outer wall or from the outer wall in. And all this is just a float type sensor or an optical sensor that's basically telling you that you have a problem either in the inner or the outer wall. Now this is a fiberglass tank. Now in a fiberglass tank, you're looking at the shape, and a fiberglass tank will normally have cylindrical with round ends. And then you're able to put that sensor in at the bottom of the tank through one of the ribs that go along the outer side. Now, they also make a steel tank. It's still a cylindrical, but most steel tanks have a flat end, and basically what they're doing is they're just going to run a pipe down to the bottom, and you actually see the secondary of this, but it's strictly just a float type sensor sitting at the bottom of this tank. And they're basically doing the exact same thing. All they're doing is letting you know whether you had a problem in the inner or outer wall of the tank. The most common one that you're seeing now is actually going into what's known as a brine-filled or a glycol-filled annular space. Now the glycol-filled tank will actually have a reservoir built on the top of it with a vent pipe up to the surface. So what they'll do is they'll fill this up with glycol, and then you have the secondary of the tank. So the problem that most people run into with this is they don't set this glycol level correctly. So as I fill and lower this inner tank, it expands and contracts, and it causes this fluid to rise and fall. But this is known as a brine or glycol annular tank. A steel tank annular or a fiberglass dry annular can either be done through a float type switch, an optical switch, or a dual float reservoir switch. So tank gauges not only monitor the level of the tank or the surrounding areas of the tank in the annular space. When you take that same example that we had before with the little dispenser, underneath this dispenser there is something, either a dispenser pan or a dispenser sump, where that piping from the tank comes up underneath the dispenser. You can actually put in a sensor here to let you know if this piping or any of the piping underneath the dispenser is leaking and collecting in this pan. You can have monitoring wells. So if I have a monitoring well at a site, I do the same thing. I'm going to put a sensor down here with a float, and I'm monitoring the water level at the facility. So basically what I'm doing is monitoring the groundwater to make sure that there's no hydrocarbon floating on the surface that comes in contact with this sensor, but you're also making sure that this float is always submerged in water. So this is a groundwater well, a dispenser sump, but we also have the very tall tanks, anything over 20 foot. We also have what's known as a flexible probe. Now a flexible probe can go up to 70 feet, and it comes in a coil in a 4-foot round circumference, but it'll come in a box. And it basically, you're just taking two people, putting on top of the tank and uncoiling this probe into the tank. Same thing, it'll have a weight, it'll have a water float, and then you have a product float. So there's multiple areas that an ATG will monitor, not only the inside of a UST, it will also monitor the product level in an AST. So we could put sensors underneath the dispenser, we could put them in the monitoring well, but there's also containment around the STP. And this is just basically doing the same thing. I'm just basically putting a sensor in this STP sump, same as I would put it in a dispenser sump or a dispenser pan, and it's just monitoring to make sure that this piping isn't leaking in here, filling this up with product or with water. Now, one of the things that you look at is there a way to be able to distinguish between just regular water or fuel? Well, there's multiple types of sensors. There's non-discriminating sensors and discriminating sensors. A non-discriminating sensor is just that. It's just strictly a float type device that when any type of liquid is inside the containment, there's a little float on the inside that raises up, setting off an alarm, letting you know that there's some type of liquid inside this area, whether it be an STP sump or a dispenser pan, a monitoring well, or a reservoir through a transition sump. When you start looking at discriminating sensors, we have the same thing with a float, but in a normal sensor, what you would have is the little floats, but what you would also have is a polycarbon band that would go along the outside of the sensor, so that if water or fuel came into contact with that band, it would lift this float, letting you know that there is a liquid there, that it is present, and then at that point it looks at this polycarbon band. Well, the band is designed to actually expand when it comes in contact with fuel, increasing the resistance of the band, letting you know that that is either hydrocarbon or water. The other way that they do it is through an optical sensor. An optical sensor just sends a beam of light to a prism, and if the light is reflected back, it knows that there's no liquid on the outside of the prism. Well, once you put liquid on the outside, this light is just reflected away and it's not returning back to the source. This is just a normal, non-discriminating sensor. By the addition of continuity pins in the interior or the exterior of this prism, what it's doing is reading continuity between these two pins, water being conductive and fuel not being conductive. It knows that there's a liquid present, and it looks at the continuity between the pins. If I've got continuity, it's water. If I don't have continuity, it's fuel. So now that we talked about what's mounted out in the field, whether it be in the tank or in the annular space of the tank, in an STP sump or a monitoring well or a dispenser pan, they have to talk to something. Well, and this is more affectionately known as an ATG console or a tank monitor. So if we mount the tank monitor inside the C-store, inside a building, we basically have to run wire to every one of these devices. And we're just monitoring this equipment through a wire going back to the building. But what you have to keep in mind is that we're monitoring fuel. So everything out in the field has to be maintained in an intrinsically safe environment. So inside this console, what you're looking for is some type of IS barrier, an intrinsic safe barrier, that can monitor this and provide power to this out in the field, but still have the ability that if I short this cable out and I just completely cut across it, there is an inability to either create heat or spark out in the field. That's what IS means. That's your intrinsic safety, is that if I have the console, which is running high voltage, powering up the devices that are out in the field, that if for some reason somebody is saw cutting and cuts across my wires, at the point in which these devices are shorted out, I have the inability to create heat or spark to be able to ignite this fuel or the fuel vapors out in the field. So when we start looking at the tank gauge in a little bit different light, think of your ATG as that nosy neighbor or the neighborhood watch. It's constantly watching everything out in the field. So everything that's going on, it's monitoring the probe inside the tank to understand what the fuel level is, what the water level is in the tank. It's constantly watching to make sure that the annular sensor is not going off, to let you know that there's a breach between the inner and the outer wall. It's constantly looking at the STP sump to know if there's any type of fluid that may be coming from the motor or from the secondary containment of the pipe. It also could be controlling the STP motor if you're running some type of line leak system, electronic line leak system. It's also monitoring the underneath of the dispenser pans, so that at any point during this, if I get collection underneath the dispenser pan, that console can then turn off a relay to shut down the motor to prevent product from going back into these dispenser pans. Well, when you take that and go out even further, you're looking at the monitoring well around the exterior of the site. These are monitoring wells that are put down to make sure that it's almost like the big brother's watching, because the monitoring wells are there to let you know that if there's any breach inside a tank that may not be picked up by a probe or a sensor, or may be coming from some other source outside the leak detection area. Because underneath the dispenser and then the STP, there are places outside of the leak detection capability of the gauge that the monitoring well would pick up that your leak detection system may not. So think about the ATG as your controlling source. It's listening, it's controlling everything, but at the point in which it finds a problem, let's say I have water in a tank, or I have a line leak, or I have fuel in an STP, at that point that it picks up, it also has the ability to notify somebody outside of the site to make sure that they're aware that there is a problem at this facility. Then that way they can go ahead and dispatch it to get somebody out there to either fix the water that's leaking into the tank, fix the union or breakaway that may be leaking underneath the dispenser, going in and pulling up the monitoring well to see if we may have something leaking at the site that's not being picked up, as well as the STP to make sure that the LLD and the STP sensors are working fine. But it's designed to notify, whether it be an email, a fax, or a text message, to someone or through an external polling solution that monitors the station to make sure that they're staying within compliance, not only for inventory management, but for your state and local regulatory requirements. Okay, so when we start looking at the ATG in general, we talked about the monitoring, we talked about the alerting, we talked about the control. But leaks don't happen at a gas station every day. But what happens every day? You're constantly dispensing in and out of this tank. So what it's designed to do is let you know when you reach the point within the tank that you need to get a delivery. So these thresholds can be programmed. So let's say you want to know when you get down to 1,000 gallons within the tank or 10 inches of product left in the tank. I can go ahead and have this where it would automatically send out a notification to either a delivery company that, hey, I need product and I'm getting ready to run low. And then it comes back as soon as your delivery is in the tank. It tells you how much product was delivered. It goes back and it gives you a delivery report. This delivery report gives you your beginning volume, your ending volume, your starting height, your ending height, the temperature of the product. It gives you the whole aspect of what was physically delivered. Now, this delivery report is going to be inaccurate. Now, the reason why it's inaccurate because people will be dispensing during a delivery. So any product that is dispensed during a delivery will not be captured. The only way that you would actually capture that is by doing what we call reconciliation, where you're tying your dispensers, the actual sales of the dispensers, into the gauge, so that way you'd have your delivery report plus equals an adjusted delivery. But that's mainly what people are using the ATG for today, is monitoring their deliveries to make sure that they're reconciling, tying it into the dispensers, tapping into the sales, monitoring what was being delivered into the tank physically, bringing the two together, and creating a reconciliation. When we talked about the ATG, we talked about monitoring, we talked about control. Well, to put both of those two things into one application, think about a generator where I'm running a day tank and I'm running a bulk tank. If the generator kicks on and the day tank gets to a level that it needs to be replenished, the gauge would automatically read the day tank level. It can close the relay, turning on the transfer pump within the bulk tank, filling up your day tank, and then once the day tank reaches its full level, it would automatically de-energize the relay, turning off the transfer pump from the bulk tank to the day tank. Another application is an oil water separator, where you can put a probe into an oil water separator tank, and the gauge is actually capable of distinguishing between the water and the waste oil that's in that oil water separator. At the point in which the level gets too high, you can set off an external horn, and that would alert somebody or send somebody an email saying that it's time to come out with a vac truck and clean out the oil water separator. Earlier on in this video, we talked about reconciliation. Well, reconciliation is tying the ATG into the dispenser somehow, whether I'm going directly into the point of sale or I'm actually listening to the two-wire. Well, if I'm going directly to the point of sale, this is just a basic RS-232 connection. But if I'm going to the ATG listening to the two-wire, I actually have to listen to the two-wire protocol going between the dispenser and the point of sale. This is where I'm just capturing, is the handle hot, how much was the last dispense, and what is the active meter totals within that dispenser. Well, whichever way I communicate, I'm actually looking at the ATG and I'm looking at the tanks that are at the site. So let's say this dispenser says that it pumped 25 gallons of regular. So once the dispensing activity is finished, I see that I pumped 25 gallons out of the regular. I see that I got 25 gallons in the regular tank. So when I'm doing wet stock management, what I'm looking for is the opening volume. Opening volume is the actual physical volume that is in that tank at the beginning of the day. So it's opening volume plus deliveries into that tank minus sales equals calculated volume. Now this is going to go on, and I'm using 25 gallons, but in a typical station you may have 1,500, 2,000, 3,000, even 4,000 gallons dispensed every day. It just depends on the size of the station and the activity that you have. Well, when I look at calculated volume, the next day I take calculated volume minus physical volume, which is my opening volume of the next day, and that will equal my daily variance. Well, when you start looking at your percentages, you're looking at either 1% of throughput plus or minus 130 gallons, but some municipalities and some local regulatory requirements are 0.5% of throughput or delivery, but you can reconcile whether it be a 7-day period, 10-day period, 15-day period, 30-day period. These could be fixed periods or rolling periods. So it just depends on the state as what the variance is. Well, then it adds this up for that period, and then it gives you your variance total. And this is what people are looking for. Well, this is why you're looking for your variances, because this is where theft comes into play. Because if somebody takes product out of the tank without going to a dispenser, you will get a variance in that product. Let's say I have a meter that is not calibrated. I now pump 27 gallons out of the dispenser, but I only saw 25 gallons drop in the tank. That will equal a variance. This is what we're talking about when we're talking about reconciliation and wet stock management. It's monitoring what was being dispensed through the dispenser, what was physically dispensed out of the tank, and coming up with a variance that adds up for either a 7, 10, 15, or 30-day rolling period. The other thing that it does is that when you start looking at variances within the tank, most tank charts are either plus or minus 5% inaccurate from the manufacturer themselves, whether it be fiberglass or steel. They try to get as close to it as possible, but what it does is that during a period, you can actually get the gauge to recalibrate the tank by using calibrated meters from the dispenser to say that if I see within the first 50 days 25 gallons leaving the dispenser and I see 27 gallons leaving the tank, I will go ahead and change the end shape or the factor in that tank to make sure that it's 25 gallons. So I'm basically recalibrating, or what the industry would call restrapping the tank, to make the tank chart that's in the gauge more accurate, which would reduce the number of variances that you have for the month, bringing your total variance within tolerance. Earlier in the video, we talked about regulatory requirements. Well, when you look at regulatory requirements, the one that we want to go over now is tank testing. Well, there's two types of tank tests that you can do. One is a static test, one is a statistical test. When we start looking at a static test is a moment in time. I'm looking for a specific level in the tank over a period of time. And the minimum at most tank testers is about 2 hours. So basically what I'm looking for is a snapshot for 2 hours to make sure that that tank's volume never changes. So when I look at a static test, I have to be 50% full for a monthly 0.2, and I got to be 90% full for an annual 0.1. Now, this is why people will buy statistical tests, because they don't want to have to take that tank out of service for long periods of time. So think about this when I'm running a static test. If I have to be 50% full for a 0.2, most of the time it takes at least 6 to 8 hours after a delivery before I can even attempt to run a static test. So you have to fill the tank up enough to get to 50%, 8 hours after a delivery, still to be able to meet the minimum monthly 0.2 requirements, and then still take the tank out of service for a minimum of 2 hours. For a 0.1, it's even more than that. I'm taking it out of service for a minimum of 3 hours. So when I look at a statistical test, now a statistical test will only get me my 0.2 that I need, but a statistical test will work in much lower volumes within the tank, and I don't have to take the tank out of service. So basically what I'm doing is that I'm looking at levels within the tank, and I'm basically just going ahead and knocking off the points that were dispensing cycles, and I'm taking all of my lines and I'm adding them together to see if I can create what is a basic static test, just to create my monthly 0.2 to make sure that the tank is not leaking. Now when I start talking about statistical tests, you'll hear words like CSLD, SLD, SCALD. We're all based off of the SITLITS protocol. So when you look at it, we're basically all the exact same. The only thing that separates us is the monthly throughput. Monthly throughput is how many gallons of product are being dispensed out of that tank every month. And we're talking about hundreds of thousands of gallons. So if I had the choice of going with a static tank test, if I'm not a 24-hour location, so if you're at a commercial industrial station or a site where they're closing down at night and you have time to run a 0.2 or 0.1 annual test at 50%, most people will go with a static test. But when you're dealing with a retail environment and I'm open 24 hours and I'm pumping constantly, especially sites that are very busy, I don't want to have to take this tank out of service. So they'll go ahead and they'll run a statistical test, but at that point you're basically just doing a static test, taking your dispensing cycles, breaking out, cutting these sections off, and only highlighting the sections of quiet time, adding them together to create a static 0.2 test. Earlier in the video, we talked about line testing as part of your regulatory requirements. One of the most common that's out there and the most widely used is probably the mechanical line leak detector. Now, a mechanical line leak detector is just that. It's a mechanical device. There's no electronics in it. It doesn't talk to an ATG. But basically what it's doing, it's looking and monitoring the pressure of the piping, the underground piping to the dispenser from the motor. And at the point in which it reaches a certain pressure, depending on manufacturing, the poppet will actually close, restricting flow. Well, at the point in which you restrict flow, and this will normally happen in cold weather, anybody that's from the north will know that on a cold night when they go to fill up the first thing in the next morning, when they squeeze the nozzle, it just trickles out. You release the nozzle, let the line pressure up again, it'll go ahead and reseat the poppet and the mechanical resets and they're able to start flowing. It's a mechanical device. Well, when you start looking at mechanical devices, we talked about the regulatory requirements. A mechanical will have to be tested once a year. They will test the functionality of the mechanical line leak detector, and they'll test the functionality for it to trip on a 3 gallon per hour line test. But what they'll also do is they'll actually do a third-party certification on the line to a 0.1 leak rate. Well, when they're doing that, they're just basically doing an overpressurization or a volumetric test on this line to make sure that the line is tight, and they'll get recertified for the year. Well, the other two that we have is pressure and volumetric. Well, pressure and volumetric are electronic line leak detectors. These are looking for leaks within the line that these are actually talking back to the console. Now, when you look at the difference between a pressurized line leak or a volumetric line leak, pressure is losing the decay of pressure over time, or they're trying to correlate pressure loss to a volume loss. Well, the restrictions that you run into that is line length and line diameter and pipe type. The other one is a volumetric test. Volumetric is where you're looking with a very accurate flow meter to actually determine how much product is leaving the line, whether it be through a third-party test or through a test through the ATG. Now, when I start looking at these, mechanical will give you a 3 gallon per hour line leak test. Now, when I look at pressure or volumetric, these have to do a 3 gallon per hour. They have to be able to run a 0.2 monthly, and they have to have the capability of running a 0.1 annually. Well, but if I run a 0.2 line test every month, I can suspend my 0.1 for up to 5 years, depending on state and local requirements. Some are 3, some are 5, but most pressurized or volumetric line tests will actually run the 3 gallon after every dispense, and then they'll try to run at least 1.2 a month and 1.1 every year. And basically what they're doing is that they're taking the motor and they're filling up the pipe with product. And they're basically looking to see if there's any pressure loss or volume loss within this pipe. Because you know that in a sealed cylinder, the only way that I can add product or add liquid to a sealed cylinder is if the exact same amount of product is leaving that cylinder. So if I have a leak in this line, the only way that I can physically add product into this pipe is by that product leaving the line. Well, in the PLLD or the pressurized piping, you will see a loss of pressure within that line if I looked at pressure over time. In a volumetric scenario, what you're looking at is you're actually measuring the amount of volume flow through a sensor, and we're actually metering out how much product is leaving that pipe. Both pressurized and volumetric line tests meet the state and local requirement for 3 gallon per hour line test, but they also meet your 0.2 monthly monitoring as well as your annual monitoring for 0.1 test. And a final note, what we talked about before is the notification or the notify piece from the gauge. Most consoles have the ability to have an optional email, fax, or text message capability. Well, when I look at my email, fax, and text message, basically what I'm looking for is an optional modem, TCP/IP connection, or some type of external GSM modem to get me the SMS. But if I have email, fax, or text message, I have the ability to push data from the console to, let's say I want to go to a delivery company. Or I will have an alarm company that's monitoring if I have water or fuel in a sump. I can send the fax to the same people, but you're basically looking at external communication from the console, getting in touch with somebody when there's an event that happened at the site, whether it be I need product now, or I've got water in my tanks, I've got fuel in an STP sump. It's pushing that data outside from the console to let somebody know at the home office or somewhere that they can dispatch somebody out to take care of the problem. Most gauges, if they have an optional modem or a TCP/IP connection in there, third-party polling companies are able to come in and interrogate the gauge, and they're polling for inventory, delivery, high water, low product, sensor statuses, whether you run tank tests, line tests. They're interrogating the gauge, and they're taking that information and storing it, but they're also supplying it out to the companies that need it, whether you're needing, if you have a contract with a delivery company to go ahead and supply you fuel, if you have a contract with a maintenance company that if you have fuel in an SDP sump or underneath the dispenser pan, they'll automatically dispatch that company out to take care of that service for you. But it also gives the ability to push data in real time, so that if I hit a low product alarm in a tank and it's July 4th, and I know that I'm going to be out of product soon, that would actually shut the station down. And most people don't want their station shut down just because they didn't get a delivery. So it's just giving you the ability to communicate outside the station to the real world, where, like I said, either be a third-party POS polling solution or somebody at the home office just running standard POS commands. But you're looking at communication, it's either through an optional modem or a TCP/IP connection or some type of text messaging service. So in summary, the reason why most people will go with an ATG, when you start looking at it, the first one is the why. Why do people need the ATG? Well, when you start looking at it, it's to meet regulatory requirement. It's to be able to fulfill your tank test and line test needs. It's to monitor for your delivery and your wet stock management and be able to go and do reconciliation. So these are the reasons why people will actually go out and buy an ATG. The how is the easy part. It's basically just installing a probe in the tank and sensors either in the annular, the SDP sump, the dispenser pan sensors, a monitoring well, a transition sump. It's basically just installing an ATG at their facility and then setting it up to monitor it and setting the thresholds that you want it to alarm. And then once you have it set, basically just telling them how do you want it to communicate out to the outside world, whether it be an email, a fax, or a text message. Do you want it to send out an email on fuel in an SDP sump? Do you want it to send it out to the delivery carrier on a low product alarm? Do you want to know when you get water in the tank? People start looking at the how as the hard part, when that is the actual easy part. The piece that you need to look at doing is going out and selling them on the why. Why do you need the ATG? That's going to be the part that you need to go back and look at trying to sell them on. Basically, why do you need it? Lower cost of ownership of your station, because you're not paying somebody to go out, go to the tank site, stick a stick in the tank, try to figure out where you're at with the gauge. And with the implementation of 40 CFR and the pressurization of the tanks, you're going to be inaccurate with the stick because the tank may be under pressure or vacuum, and that will distort your actual tank inventory readings by 3 to 4 inches, either plus or minus. Then you start looking at the regulatory requirements. Tank test, line test, things like that. Paying for somebody to come out to do a third-party exam, whether it be a tank test or a line test or even a mechanical functionality test. These are all the things on why they would need it, and it's actually going to save them money over the long run. Thank you for the time that you spent. I hope this has been helpful, and if you have any questions, contact your local OPW FMS DM or commercial district manager. Thank you.